This is a question from Statistical Mechanics, JEST 2022, in which a large system is given, a system which is very, very large. Okay. And this system is at 27 degrees Celsius. That means it is at 300 Kelvin. And they are saying that some energy is added to it. So they are saying that some 1 electron volt energy is added to this system, and because the system is large, its temperature is almost constant. Okay, temperature is not changing, but suppose initially it was at having number of microstates omega 1, and finally it is having number of microstates omega 2. So they are saying by what factor this number of microstates will change, that number we have to tell, the order of that number we have to tell. So let us go by the basics, that initially entropy will be S1 is equal to Kb ln omega 1, and finally after addition of 1 electron volt of energy, it will become Kb ln omega 2. So if I calculate change in entropy, it will be given by uh, Kb ln, if I am subtracting this, it will become omega 2 by omega 1. Okay, so now we know that the entropy delta S is given by delta Q by T. So I will put here delta S uh, by, in the place of this, delta S will be equal to delta Q by T, which will be equal to Kb ln omega 2 by omega 1. Okay, so this energy that is added is given to be 1 electron volt, and the temperature is 300 Kelvin. Okay, so temperature is 300 Kelvin. Okay, and this is equal to Kb ln omega 2 by omega 1. So just we have to be careful that this energy is in electron volt and this is in K. So 1 electron volt, there is a conversion factor that is given, that is equal to 11600 K. So I will write in the place of this energy, I can write this, put it this in Kelvin with the 11600 K. But you know, this is dimension of energy. So this was dimension of energy, and you have put substituted it in Kelvin. So there will be a Boltzmann constant also, okay, in this conversion, and this Boltzmann constant will be cancelled here, and this will also become dimensionless. This ratio will become dimensionless. Okay, so now ln of omega 2 by omega 1 will become 11600. So let us cancel this also. So this will become 38.6. Okay, you divide this. This will become 38.6, and now omega 2 by omega 1 will become e to the power 38.6, and you can use the calculator to get this number. So that will be equal to 4.46 into 10 to the power 16, and roughly that is equal to 10 to the power 70. So this is the procedure, a very straightforward one. Just I have used the Boltzmann formula, S is equal to Kb ln omega, that you all know. Just you have to, in many questions I have told many times, just you have to go step by step what they are saying. And the first thing, after reading the question carefully, you should try to correlate what is that relation which you know in that particular case. This is very basic but very, very important. Like for example, in this case, if they are talking about a system and the change in entropy, and they have given energy, so we know that there is a relation between entropy and that energy. And this was that particular constant temperature, so I have used delta Q by T. Okay, thank you.